In this video, we are going to cover distance time graph. Some of the topics has already been taught to you in the live class. The graph here shows the distance covered along the vertical axis, that is y-axis, and the time is shown on the x-axis, that is horizontal axis. The graph shows the distance traveled by a particle from a fixed point over a period of 5 seconds. Calculate the speed of the particle. Speed, as we know, is distance over time. So distance covered is 25 meter, time is here 5 meter. So 25 by time gives you 5. So that is the answer. Now the next part, Bill and Ben are brothers. Bill lives in Gloucester and Ben lives in Cheltenham. Each morning Bill travels to work in Cheltenham and Ben travels to work in Gloucester. Calculate Bill's speed. Bill travels 6 miles in 10 minutes. You can see here it is mentioned 10 on the graph and the distance covered is miles, because here it is mentioned miles. 6 miles in 10 minutes. 1 hour is 60 minutes. So in 1 hour he would travel 6 times 6, that is 36 miles. Bill's speed is 36 miles per hour. I hope so far everything is clear. 6 miles in 10 minutes. So how many miles in 1 hour? That you have to. 6 miles in 10 minutes. In 10 minutes. Now 60 minutes is 1 hour. So you multiply this 10 by 6, you get 60 minutes. Similarly, multiply this 6 by 6, because you have multiplied here by 6. This side also you have to multiply by 6, so that gives you 36 miles. That is 36 miles in 60 minutes. Or we can say 36 miles in 1 hour, 1 hour, which is equal to 36 miles per hour. That is how we calculate. This is pronounced as per. 36 miles per hour is the speed. So far it is clear, hopefully. So we found Ben travels at a speed of 60 miles per hour. Assuming he leaves home at same time as Bill, draw a line on the diagram to represent Ben's journey. Now, from the diagram, the distance between Cheltenham and Gloucester is 6 miles. Ben is traveling at 60 miles per hour. So 6 miles will only take him 1 by 10 of an hour, that is 1 by 10 of an hour, that is 6 minutes. This line indicates the purple one, Bill's journey, and the purple one indicates Ben's journey, and the blue one indicates Bill's journey. If they both leave home at 8 a.m., at what time do the nearest minute do they pass each other? So when you draw these lines, they will meet at this point. You can see my cursor. Drop a perpendicular, and you can see it reaches here at around 4 minutes. So time would be 8:04. The brothers pass each other at 4:84 a.m. to the nearest minute. Next question that is asked is, how far are they from Cheltenham at this point? Give your answer to the nearest 0.2 miles. So that is the point you can see. You have to calculate how far, that means it is asking you distance. Reading of the vertical scale, the distance from Cheltenham where they pass each other is 3.8 miles. You can see this distance. This indicates the distance. It is a little less than 4, so 3.8 miles. This graph shows the distance covered by a sprinter during the first 5 seconds of a 100-meter race. You can see the graph. The height of the steps shown on the graph increases from left to right. See, the height of the graph is this, the vertical line. That is increases as you move from left to right. This is the smallest, this is a bit larger, this is larger, still larger, and this is again the largest. This shows that distance traveled over 1 second interval are increasing. So every 1 second, 1 to 2, see this distance, now 2 to 3, see this distance, it is increasing. 3 to 4, again 1 second interval, the distance is increasing. Again 4 to 5, this distance. So at every second, the distance, vertical height is increasing. What does that indicate? In other words, the sprinter is gaining a speed. When speed is increasing, that means the sprinter is gaining a speed. Now take a look at this graph. You will notice at every passing second, the vertical distance is decreasing. This time the height of the steps decreases from left to right. From left to right, the distance is decreasing. So the distance traveled over the 1 second interval are reducing. What is the situation? What kind of situation is here explained? Suppose something is applied a brake suddenly, it stops slowly. So every passing time after the brake is applied, the car comes to rest. That scenario is being explained in this graph. This is what we would expect as the car is slowing down, correct? Here are two sketches of distance time graph for a practice particle related to a fixed point P. Describe the behavior of particle in each case. See here, this line shows the distance from P and this is showing time. So distance from P. Now describe the behavior of particle in each. So what is the behavior of particle? The first one is, at first the particle moves away from P at constant speed. It is moving at a constant speed because the line is straight. This is shown by a straight line. You can see from the purple one is straight part, so it is moving at a constant speed. Then the particle then reduces the speed and stops. Speed is reducing in this part and it is stopped at this point because it is now parallel. This is shown by the curve reducing in steepness and becoming horizontal. Stopped means when it is horizontal, the distance covered is 0 and speed and time is passing. So the speed is distance by time, so 0 by time is, so it will be stopped. It is a stopped situation. So from here to here increasing, then slowing down and here completely stopped. Now let us take a look at this graph. The particle is initially at rest because time is 0, initially at rest, some distance from P, and it is at some distance from P. This difference shows the some distance, and time is showing 0 because it is here. This is shown by the horizontal straight line. Horizontal straight line, so initially at rest till here. Then what happens? Then moves down towards P. It is moving towards P. The particle is moving towards P. As it gets closer and it is coming close to P, if you take a careful look, this point is here, next point is here, so it is closer to P after every passing second. The curve shows that change of the distance occurs at increasing rate, so it is speeding up. Here the graph shows the progress of two runners, Cass and Sally, during a 10-kilometer race. The purple one is Sally and the blue one is Cass. Compare the strategy of the two runners over the first half of the race. Cass covers the first half of the race at a constant speed. Cass is blue one, it is constantly increasing. Sally's graph has a steeper line. This is Sally's graph, it is steeper. This means Sally sets off quicker than Cass. So this is at a faster speed. If the line is steeper, then it will show that the speed is faster. Sally tries to maintain a higher constant speed than Cass, but stops to rest after 15 minutes. She is going at a higher speed than Cass because this is steeper. Then take rest after 15 minutes. 15 minutes is this point, 1/4 of an hour. This line, so take rest here, then stops for some time. This distance is showing this much time she is stopped. The horizontal line shows that Sally stopped, yes. Compare the strategy of the two runners over the first half. Cass overtakes Sally, then Sally sets off after her but at a slower constant speed. Now if you take a look, this is Cass speed graph, this is Sally. Sally is at slower because if you notice the graph, Cass is at a higher speed. The graph intersects at the point where Cass and Sally overtakes. At this point, they overtake. Cass reaches the halfway point about 5 minutes before. Halfway point, she reaches 5 minutes before Sally. What happens to the point corresponding to P on the graph? At this point, what is happening? In the second half of the race, both runners maintain a constant speed to the point P. Both are running at a constant speed because line is straight. The steeper line for Sally, Sally's line is steeper, shows that she is running faster up to point P. So Sally is running faster because this is steeper. Both runners then increase speed, but Cass is now running faster. Now at this point, who is running faster? This one is steep. So now CAS is running faster.